Hi everyone. So today we will be discussing the January 2021 M2 paper. Question number 1. A particle P of mass 1.5 kilograms is moving with velocity 4i plus 6j meters per second when it receives an impulse of magnitude 15 Newton seconds. Immediately after P receives the impulse, the velocity of P is Vi meters per second. Find the two possible values of V. Okay, so there are a few, when you read this, when you go through this question, you can see they've given you the initial velocity in terms of ij, like they've given you a vector quantity. Final speed, the final velocity is also given in terms of ij, which means it's a velocity component. But you can see the impulse is given what? The impulse is given, they have given you the magnitude of the impulse, not in terms of ij. So basically what you do here is first, let's use our equation I equal mv minus mu. Let's input our v and u values in terms of ij and let's get the impulse in terms of ij first. So what do we get here? I equals mass is 1.5 v. The velocity after impact is, the velocity of p is after receiving the impulse, it's vi. So it's vi. So v component and here j component is 0. Vi plus 0j. And then minus mass is again 1.5 u. Initial velocity is 4i plus 6j. So I wrote it in the column vector form. So let me, or else you could write with ij, there's no problem. So I get here 1.5 v. 1.5 into 4, what do we get? So I get here 6, right? So 1.5 v minus 6. So this is the x component. The y component, what do we get? 1.5 into 6 we get 9, right? So we get here 1.5 into 0 is 0. Minus 1.5 into 6 should give me minus 9. So these are my I components. Basically, I get I as 1.5 v minus 6i minus 9j. This is my impulse. So now what we do is we will square and we'll square the components and take the root of it and find the magnitude. So that's how we find the magnitude. So to get the magnitude, 1.5 v minus 6 whole thing square plus minus 9 u square, and then we root it. This is how we get the magnitude. So this is equal, the magnitude of the impulse is equal to 15. So 15 equals 1.5 v minus 6. How much do we get here? 1.5 v. I will remove the root. Shall we square both sides and remove the root? So we'll square both sides. It removes the root. I get here 15 square. I get here 15 square. I get here 1.5 v minus 6 into 1.5 v minus 6. Or I'll keep it in terms of 1.5 v minus 6 square minus plus minus 9 square is 81. 15 square minus 81 and I get 144, right? So it's better to keep, I mean, we don't need to open the bracket, because if you open the bracket, you'll end up getting a quadratic equation with v and you'll have to simplify the coefficients and take. So I rather keep it like this and we'll remove the square and get the coefficient. So I get here 144, the square root. I'm removing the square as a root, and you remember you need to put plus or minus. And I get 1.5 v minus 6. So plus or minus root 144 is 12 equals 1.5 v minus 6. So let me separate. I get here 1.5 v minus 6 equals to plus 12, or 1.5 v minus 6 equals to minus 12. So I get here v equals 12 plus 6 divided by 1.5, or v equal minus 12 plus 6 divided by 1.5. So simplify. 12 plus 6 is 18. 18 divided by 1.5 gives me 12 meters per second. On the other one, minus 12 plus 6 is minus 6. Divided by 1.5 gives me minus 4 meters per second. So these are the possible values of v. They ask you to find the two possible values of v. Question number 2, the uniform lamina ABC has sides AB equal AC equals 13A and BC equals 10A. So it's a uniform lamina, a triangular lamina, and you can see two of the sides are equal, which means this is an isosceles triangle. Okay, so they say here the lamina is freely suspended from A. So it's already hanging from this point. Okay, so make a note of that it's hanging at this point. They say a horizontal force of magnitude F is applied to the lamina at B. Okay, so you apply a horizontal force at B as shown in figure 1. The line of action of the force lies in the vertical plane contained in the lamina. The lamina is in equilibrium with AB vertical as they have shown in the diagram. The weight of the lamina is W. Find F in terms of W. It's just 5 marks. Okay, the first thing is you need to find where the weight of the lamina is acting. So where does the weight act? Normally the weight acts at the center of mass of the lamina. So you can see it's an isosceles triangle here. In an isosceles triangle, the center of, an isosceles triangle has what? It has a line of symmetry. An isosceles triangle has a line of symmetry and it makes a 90 degree. The line of symmetry makes a 90 degree at this point. So basically in a triangle, the center of mass lies in a 2:1 ratio, isn't it? You have learned it in your M2 book. When you have triangle, the median method. So this ratio, when you draw a perpendicular and when you draw perpendicular to this side, these the place where you meet, the place where the medians meet is the center of mass, and it divides the ratio 2:1. It divides the length of the side in the ratio 2:1. So basically what you do here is, let me take this distance as A, B, C. Let me take this point as D. Can I have the AD distance first of all? What would be the AD distance? We'll use Pythagoras theorem. So AD distance would be, it's a right angle triangle here. This is 13A. This should be 5A, right? So AD would be 13A whole thing square minus 5A whole thing square root. Do you agree with me? So 169A square minus 25A square root gives me how much? 169 minus 25 is 144A square. So taking it out of the root, I get 12A. So AD length is 12A. So now what do we know? We know the center of mass lies somewhere over here, and the center of mass lies in the ratio what? It lies in the ratio 2:1. Basically, this 12A length, AD distance 12A is divided in the ratio 2:1. Okay, so can you all find the AG distance in that case? So AG will have a ratio of 2, GD will have a ratio of 1. Always the the ratio part 1 comes to the side where you have the 90 degree. Okay, so 2:1 ratio. Let's get it done. So what do we get here? AG equals 2/3, right? 2:1 ratio. So 2 parts out of 3 from the entire length 12A. How much do we get here? 3 times 1 is 3, 3 times 4. So we get here 8A. Do you realize AG length becomes 8A? So AG length is 8A. So this is the most important thing you need to find here. And now what we do is we mark the weight. The weight acts at the center of mass of the lamina. So here this is the place where you have the weight. Okay, so this is the weight W acting. Now, since we found the position of the center of mass of the lamina, we need to find F in terms of W. And they have told you very clearly it's suspending from A, right? So when you're suspending from A, and if you want to find G in terms of W, now this is in equilibrium, right? So when an object is in equilibrium, what we do in M2 is we either go for horizontal equilibrium, or we go for vertical, or we take moment. So in this situation, the most appropriate thing to do here is, since there is since it's already hinged at this point, okay, so it's better that we use moments around the place where you suspend, because there are unknown forces acting at this point A. So better that you use moments around point A so that you don't have to deal with any of those unknown forces. Okay, take moments around point A. So the challenge here is to get the distances properly. Okay, so how do we get the distances? Okay, so now how do we take the moments here? Okay, we are going to take moments around A, and the biggest thing here, the most important thing here is to consider the distances. Okay, so let's take moments around A starting with the force F. Now force F gives a clockwise moment or an anti-clockwise moment. When I take moments around A, you can see force F gives what? When you pull it this way around A, you can see around A, it gives a clockwise moment, right? So force F gives a clockwise moment. So let me say clockwise is positive. So positive F moment is force into distance. So what's the perpendicular distance between F and point A? What's the perpendicular distance between F and point A? You can directly see it, right? F is going in this manner. The perpendicular distance from A to F is 13A. Is that clear? And then what you do is, the next thing is you need to consider moments from around A with the force W. That's the other force we have. So W gives what kind of moment? So you can see W force goes from here, way over here, it comes down. So what kind of moment does W give? Clockwise or anti-clockwise? So you can see here when you pull this down, W gives a anti-clockwise moment around A, right? So then the most important thing here is to calculate the perpendicular distance. Okay, think about calculating this perpendicular distance. So I need to get this perpendicular distance. How do we find this? So what you do here is the same distance D, I'll take it from here. The same distance D, I'll take it from here. And let's say this angle is theta. Okay, so we need to find an angle here, this theta. So basically, if I know the theta angle, I could say D is actually what? In an event, we know the theta angle, we could say D is, you could resolve the 8A, right? Because with AG, you could resolve. There's a right angle triangle here, and you could resolve and say D distance is 8A, not cos, but 8A sine theta. Do you agree? D is equal to 8A sine theta. You take the AG distance and you resolve it. So towards the angle, the vertical distance, this distance would be 8A cos theta. This distance would be 8A sine theta. Okay, now the thing is, now that's the perpendicular distance. Basically, that's our perpendicular distance between point G and A. But we now need to find what? The value of sine theta. How do I find the value of sine theta? To find the value of sine theta, what I'll do is I'll consider this large triangle here. Do you see the large triangle ADB, which is also what type of triangle? It's a right angle triangle. Do you agree with me? ADB is a right angle triangle. Can't I find the sine theta value from the right angle triangle? Sine theta is opposite over hypotenuse. Opposite over hypotenuse. So opposite is 5A. Hypotenuse is 13A. Do you see I can find theta by using this large right angle triangle? A to A cancels and I get sine theta is 5 over 13. So now I have my sine theta value as well. So that means my perpendicular distance from G to A is 8A. Sine theta is 5 over 13. Which means my perpendicular distance is 40A over 13. It's D distance. So that's what I need to find the moment, right? So then the moment W gives an anti-clockwise moment in this direction, which means it's minus W into, what is it, 8A sine theta. Once I found the distance is 40A over 13 equals to what? There are only two forces here, and since it's in equilibrium, it must be equal to 0. So now making, we need to find F in terms of W, making F the subject. W into 40A over 13. So basically here the F equals to W times 40A over 13, and you bring the 13A down. The A to A would cancel out, and I get here F equals 40W over 13 times 13 is 169. So this is the answer for F in terms of W, 40W over 169. Question number 3. A car of mass 600 kg travels along a straight horizontal road with the engine of the car working at a constant rate of P watts. The resistance to the motion of the car is modeled as a constant force of magnitude R newtons. At the instant when the speed of the car is 15 meters per second, the magnitude of the acceleration of the car is 0.2 meter per second square. Okay, first shall we draw this, because afterwards they say the car is traveling up along a So there is an inclined straight road. Okay, first we'll draw the first diagram. A car of mass 600 kilograms. A car of mass 600 kilogram travels along a straight road with the engine of the car. So the power, basically P watts means it's the power. The power is P watts. And they say that, so basically if there's a power, it means the car, I mean the engine of the car is producing a what force? The engine of the car is producing a driving force because of the driving, because power equals driving force into velocity. Isn't it? Power equals the attractive force or the driving force into velocity. So basically, for there to be a power, there must be a driving force produced by the car. They say the resistance to the motion of the car is modeled as a constant force of magnitude R newtons. So resistance is R newtons. At the instant when the speed of the car is 15 meters per second. So they've given you at the instant, at that particular instant when the velocity is 15 meters per second. When the velocity is 15 meters per second, the acceleration of the car is 0.2 meters per second square. Then, okay, so this is the first piece of information they've given you, right? Yeah. And then the weight of the car is 600 kilograms. So that's the vertical forces. Okay. Then they say later the same car travels up a straight road, inclined at an angle theta to the horizontal. So it's really important. You see, it travels up. Okay. Later the same car travels up. So draw another diagram. The same car, I'll draw it over here. The same car travels up the straight road. The angle, inclined angle is theta. And they have told you here sine theta is 1/20. The resistance to the motion of the car from non-gravitational forces is modeled as a constant force of magnitude R Newton. So again here, now once again you need to realize the car is moving. They say it's moving up, right? It's the same car travels up. And they say here, so if it's traveling up, the resistance should be acting down. The resistance is acting down. And they say here, when the engine of the car is working at a constant rate of P watts. So again, they say the power is P watts. Okay, so there are, you need to realize here, so there is a driving force again produced by the car. But this time, don't use the same driving force, use a different one. For this one, I'll use D1. For this one, I'll use D2. The driving force will vary because you are now traveling up a hill, and there will be a slight differences in this diagram. So your driving force should change even though your power remains the same. Okay. So the car has a constant speed of 10 meters per second. They say the car is moving at a constant speed of 10 meters per second. There's no acceleration here at all. Okay. So let's mark all the forces they are asking you to find the value of P. Basically, to find the value of P, you need to use the information from both the diagram and create two simultaneous equations to find the P value. Okay, so what do we do first? I think my force diagram here is complete, just the weight and normal reaction, which is really not necessary because we consider only the horizontal forces. However, in here, in the inclined plane, you need to consider all the forces. Basically, even the weight is what? 600 G. And then the components, because we need the components. So this side I'll have 600 G cos theta, and this side you'll have 600 G sine theta. Okay, and then don't forget you also have what? The normal reaction. This is clear. So these are all the forces, right? The weight components, the resistive force, the driving force, the normal reaction. These are all the forces that we need to mark, right? Now we need to what? In this situation, in this particular situation, there is an acceleration. So we need to apply what? F equals ma and get the equation. But in this situation, you are moving with constant velocity, which means the forces are balanced. Okay, so what we'll do here is let's apply F equals ma to the first diagram. Going to the right. So frontward force is D1 minus normal reaction equals mass into acceleration. Mass is 600, acceleration is 0.2. Shall we input the value of D1? What do we know about the power? Power P is equal to driving force into velocity. So driving force is D1 into velocity is 15. Do you agree with me? Shall I make D1, shall I input the value of D1? D1 is P over 15. Is that okay? So I'm going to replace D1 as P over 15 minus R equals 600 times 0.2 is how much? 120, right? 600 times 0.2 is 120. So this is the first equation using F equal ma. Now go to the second equation. In the second equation, what do they say? They say the object is moving at a constant velocity, which means if the object is moving at a constant velocity, it means the forces are balanced. So how do we balance it out? The driving force upward is equal to what? 600 g sine theta minus, plus r. 600 g sine theta and r is balancing out with the driving force with the d. Okay, so that's why I mean there's no unbalanced force. There's no acceleration. Basically, forces are in complete harmony. They're in balance. That's why the car is moving at constant speed. Okay, so again for D2 also we'll write the power produced in this case is also P, right? They say for both the cases the power produced by the engine is P. So I'll write the power equation again. Power equal driving force into velocity is in this case 10. Power equal dV, driving force into velocity. Basically my driving force 2 is P over 10. So now this time replace D2 with P over 10 equals 600 G sine theta plus R. So now what? We have a pair of simultaneous equations. It's a matter of solving these two equations and getting the value of your P. Okay, so let's input the value. Shall I make R the subject from the first equation? When I make R the subject, I get R equals P over 15 minus 120. So let's input the value here. P over 10 equals 600 G sine theta plus R is P over 15 minus 120. Okay, so let's add everything together. P over 10 minus P over 15 equals 600 G sine theta minus 120. Sine theta was given to you as 1 over 20. P over 10 minus P over 15. How much is it? 1 over 10 minus 1 over 15. 1 over 10 minus 1 over 15 gives me 1 over 30, which means in this case it's P over 30, right? Because we have the P value. So P over 30 equals, so in this case, again, we give the value of G as 9.8. So the moment you give the G value as 9.8, make sure you give a maximum significant figure of how much? Only 3 essay. Okay, it can even be 2 significant figures. The moment you use G as 9.8, you must give your answers only for 3 essay. So it's 600 into 9.8, 600 in 9.8 into 1 over 20 minus 120 equals 174, and P equals 174 multiplied by 30. So 174 multiplied by 30 gives me 5220. This is already in 3 significant figures, right? 5220 watts. Okay, so make sure in an event, if you do get some more extra significance, you must make sure to reduce it to 3 significant figures, or else you will lose marks. Okay, so maximum they are allowing you is 3 significant figures. You can even leave your answer 2 significant figures. The number 4 shown in figure 2 is a rigid framework made from 3 uniform rods, AB, BC, and CD, where AB is equal to 6A, BC is equal to 5A, CD is equal to 4A. Do you see that it's made up of 3 rods? So they say here point E is on AB, where BE equals to 4A, CE equals to 3A, and angle CEB equals to 90. So this angle CEB is equal to 90. The 3 rods are all made from the same material and they all lie in the same plane. The framework is suspended from B. Okay, so they're hanging this from B, and they ask you and hangs in equilibrium with BA at an angle theta to the downward vertical. Find theta to the nearest degree. Okay, so how do we find the theta? Before finding theta, the first thing you should do is you should find the center of the center of mass. You should find the coordinates for the center of mass. So it's a framework. In a framework, the what contributes to the weight? What contributes for the mass? We don't have area here. So in a framework, the weights of the individual frames, the individual rods will contribute to the weight. And when it comes to the weight of the rods, what we do is we take the length. We say the length is corresponding to the mass. Okay, the length is corresponding to the mass. Okay, so shall we get the work here? Okay, let's find the x bar, y bar. So you need to choose a certain coordinate as 0, 0. Now at the end of the day, they ask us to find, we are suspending from B and we need to find the center of mass coordinates from where? From B, right? Now you could use 0, 0 as C, but then in this case, I think it's a lot easier if I go with 0, 0 at B, right? So I'll use 0, 0 at B. So to the left side of B, it's negative coordinates. To the right side of B, it's positive x. Okay, so you can see the entire framework is below B, right? So because the entire framework is below B, all my y coordinates, I'll just use positive y coordinates because everything is below B. But when it comes to the x coordinates, certain x values are to the left and certain x values to the right. So the left people, I'll go with negative. The right people, I'll go with positive. Okay, shall we mark all the coordinates? Okay, so at 0, 0, can you tell me the coordinates of Z? We go 4a down, 3a to the left. So the coordinate should be minus 3a. Y coordinate, I'll take it as 4a. Okay, so this coordinate is minus 3a, comma 4a. The y coordinates, as I told you, I'll be using all the y coordinates positive. What about the d coordinate? So d, the x distance is how much? The entire CD distance is 4a, isn't it? So if the entire CD distance is 4a, that means this distance is 1a, which means the x coordinate at D is a comma, it's to the right. So it's a comma 4a. And the last coordinate I want is at A. So at A, the x coordinate is 0 because we are in the same vertical line. The y coordinate will be, what's the BA distance? BA is, AB is 6a. So it's 6a. Are there any questions about the coordinates here? Check on the coordinates. Okay, so now what we'll do is we'll consider each and every rod, take its mass and take its center of mass and take moments. Okay, shall we? So let's take first one, the rod BC. So rod, the object, mass, and the center of mass. The first one, I'll take the rod BC. So what's the mass? Mass is proportional to the length. What's the BC length? 5a. So 5a. Okay, and then what about the center of mass? Center of mass of the rod lies in exactly in the center, in the middle, right? So how do you get the middle coordinate of the rod? You can add the two, the corner coordinates and divide by 2. So add and divide by 2, 0 minus 3. When you add and divide by 2, what do you get? Minus 1.5a for the x coordinate. Y coordinate is 0 and 4. Add and divide by 2. It's 2a. And then the next one is CD. So CD rod, when we take it, how much is the mass? CD is 4a, right? 4a. And then the center of mass is in the middle. So take the middle of the coordinates, minus 3a, comma 4a, a, comma 4a. Add and divide by 2. Minus 3a plus a, when you divide by 2, what do you get? Minus 3a plus a is minus 2a. Minus 2a divided by 2 is minus a. 4a plus 4a is 8a divided by 2. It's again 4a. And then the next one, the next rod is BA. So BA is 6a, right? The length is 6a. Center of mass coordinate, add and divide by 2. 0 plus 0 divided by 2 is 0. 0 plus 6a, add and divide by 2, it's 3a. And then finally, let's get the total framework. Total framework mass will be, you add everything here, right? 5, 4, 9, 9 plus 6, 15. A, and the center of mass coordinates are x bar, y bar. Now remember, I find my x bar, y bar from with respect to what point? I have used B as 0, 0. Therefore, I am getting my center of mass coordinates from the point B. Okay. So now let's use moments. Basically, multiply the x mass and the center of mass. 5a into minus 1.5a plus 4a into minus a plus 6a into 0 equals total is 15A times X bar. So can you all multiply? What do we get here? So let's get the answer. How much do we get here? Multiply quickly. 5 times minus 1.5 plus 4 times minus 1. So basically 4 times minus 1A. So 4 times minus 1. 6A times 0 is 0, isn't it? So here 5 times minus 1.5, 4 times minus 1. I get here minus 23 over 2. Minus 23 over 2. What? We get here, do you see A into A into A? All of these are A square values. Do you agree with me? This is 15A times X bar. So divide. So minus 23 over 2 times 15A, 23A square. So how much do we get here? 23 over 2 times 15. And I get 23 over 30. A, 1A will cancel out, negative. A single A value will cancel out here, minus 23 over 30A. Okay, so this is the center of mass distance from B. Basically, minus means what? Minus means my center of mass coordinate is to the left. My G value is to the left of the framework. Okay, left of the BA line. That's why it's negative, because I use the left side as negative. Then let's get the Y coordinate as well. What's the Y coordinate? 5A into 2A, the mass multiplied with the center of mass Y coordinate, plus 4A into 4A, plus 6A into 3A equals total mass is 15A times Y bar. So when you add everything, this is 10A square, 4 times 4 is 16A square, 6 times 3 is 18A square, equals 15A times Y bar. Add all these, what do we get? 10 plus 16 plus 18. And I get here 44A square equals 15AY. Y is 44A square divided by 15A. And we get Y as what? 44 over 15 is simplest. Yeah, it's the simplest. So A, you can remove A, 44 over 15. This is your Y bar coordinate. Is that clear? So this should be 44A over 15. There's a single A term remaining here, right? Okay, so now it's time to find an angle. How do we find the angle? So to find the angle, they say that they're suspending from B. So I have my X and Y coordinates here, the X bar, Y bar. So basically they want us to find the angle with BA and the downward vertical, right? So BA and the downward vertical. Basically when you draw it, so this is the downward vertical. Do you see the suspending point and the center of mass? The place where you suspend and the center of mass is your downward vertical. And then they want the angle between what? BA and the downward vertical. This is the theta that they want you to find. How do I find this theta? So to find this theta, we'll construct a right angle triangle from here like this. Do you see? I already found these two values. This distance that I have over here is my Y bar. Isn't it? We found the Y bar, and this distance that I have over here is my X bar. So can't we find tan theta now? So let's find tan theta. I'll find it on top here. Tan theta is opposite over adjacent. So opposite is the X bar. So opposite X bar was how much? 23A over 30, right? X bar was 23. Now it's negative here. Now we got here X bar is negative. The reason we got negative is because it's behind B. So anyway, do we need to input the negative value here when we are getting tan theta? No, you are only putting the length. We are only interested in the length. So you don't, please do not give the negative sign. Okay, just give the length from to get the tan theta. So 23A over 50. 23A over 50. You divide this by Y bar. What was the Y bar that we got? Y bar was 44A over 15, right? So divide, get the answer. Simplify 23A over 50 multiply by 15 divide by 44A. A to A will cancel out, simplify, get the do tan inverse, get the theta answer, and they want okay, and so 23 over 50 into 15 over 44 gives me 69 over 440. Let's get tan inverse of the answer. And I get, okay, yeah, my x bar value was 23 over 30, right? Yeah, the x bar value was 23 over 30 divided by the y bar value 44 over 15. So let's get it again. 23 over 30 into 15 over 44. So tan inverse of answer gives me 14.647. Basically, give your answer to 3SF. So you get 14.6. Or have they told you to give the answer to the nearest degree? They are told to find the nearest degree. So basically, to the nearest degree, 14.6 becomes 15 degrees, isn't it? So I hope all of you understood how to find the angle here. Question number 5. At time t seconds, where t is greater than or equal 0, a particle p has velocity v meters per second, where v equal 5t square minus 12t plus 15i plus t square plus 8t minus 10j. When t equals 0, particle is at the origin. Basically, that means at time 0, particle is at the origin, means since it's in terms of ij, our question vector should be 0y, 0j. Okay? And then they say at time t seconds, P is moving in the direction I plus j. So they have told at time capital T seconds, P is moving in the direction. They've given you a direction. This is something similar to what you've done in M1 vectors as well. So when they say the particle is moving in a particular direction, who do you consider with directions? So basically, the velocity vector is the vector that considers direction into account, right? The direction of the object. I mean, you can see the direction that of your particle by considering the velocity vector. So basically, when they tell you that the particle is moving in this particular direction, consider the velocity vector. So your velocity should be parallel, or your velocity is in the direction of I plus j. Okay, so this is what you need to consider. So 5t square minus 12t plus 15i plus t square plus 8t minus 10j. To remove the parallel, you can put a constant. All right, so you put a constant and you can equate and you get here I plus j. Okay, so then what we do is we can equate the I coefficients. I get here 5t square. They've told us to, 5t square. They've told us to input t as capital T, right? At time capital T. So input t as capital T. So I get here 5t square minus 12t plus 15. The I coefficient is equal to, on the other side, I get ki, which means the I coefficient is k. And for j coefficient, I get here t square plus 8t minus 10 is equal to kj, which means k. So then what we could do is we could, since both of these equations are equal to each other, either you could divide them and you could get rid of the k, or you can just make them equal to each other. So I'll make them equal to each other. 5t square minus 12t plus 15 equal t square plus 8t minus 10. What do we get here? T square, 5t square minus t square is 4t square minus 12t minus 8t is minus 20t plus 15 plus 10 is plus 25. So get all the factors here. What do we get here? I think we get the same factor repeated twice, right? So you get 2t minus 5 and you get only one answer, 2t minus 5. Basically, your t value is 5 over 2. Capital T will be equal to 5 over 2. Part B, when t equals 3, P is at the point A. Find the magnitude of the acceleration of P as it passes through A. So how do I find the acceleration? First thing is, before going for magnitude of acceleration, first find the acceleration as a vector. The acceleration vector, how do we find acceleration vector? velocity is given to you, right, in terms of ij. So what do we do? We differentiate the velocity and find our acceleration. So what do we get here? Differentiate acceleration equals 5t square minus 12t plus 15. When you differentiate, we get 10t minus 12y. And here that's inside, that's the I coefficient. The j coefficient would be 2t plus 8 with j. So then we got the acceleration vector. So now input t as 3. So acceleration equals 10 times 3, 30. 30 minus 12 would be, we get here 18i. 2 times, replace t with 3. 2 times 3, 6. 6 plus 8 is 14j. So this is the acceleration vector. So now find the magnitude. How do you find the magnitude? You square it, 18 square plus 14 square, square root. So what do we get here? Root 520, which is 2 root 130. So you could leave your answer like this, or you could give it to 3 significant figures, which is 22.8 meters per second square. Okay, then moving on to the next part, they say find the position vector of A. Okay, so position vector of A means what? You need to find the coordinate at time equal 3, because at time equal 3, the point P is at A. So what do we do to get the position vector? Basically, the velocity vector is given, we integrate. So velocity vector, when you integrate, you get the position vector R. So integrate 5t square, integration is 5t cube over 3 minus 12t integration is 12t square over 2 plus 15 integration is plus 15t. That's the I coefficient. Similarly, go ahead with the j coefficient. T square is t cube over 3 plus 8t is 8t square over 2 minus 10 integration is minus 10t. This is j coefficient. Once you're done with integration, make sure you put a plus c. So let me write it down properly again. 5t cube over 3 minus 6t square plus 15ti t cube over 3 plus 4t square minus 10t times j. Do you agree? And plus c. So how do we find the plus c value? When you integrate, you must remember to put the plus c. How do we get the plus c? So they've told us at the very beginning, at time 0, the particle is at the origin. So that means at time 0, you are at the origin, means your starting position vector is 0i, 0j. So at time 0, R is 0i, 0j. So input R as 0i, 0j times 0. What do we get here? Times 0, these guys, the whole thing becomes 0i. Here input everything as 0, we get 0j plus c, which means your c is going to be just 0. So that means I can now write my position vector R equals 5t cube over 3 minus 6t square plus 15ti plus t cube over 3 plus 4t square minus 10tj. So c value is 0. Now what do we do to find the position vector? Now this is my position vector equation. Replace the t value with 3. So replacing t with 3 gives me R equals 5 times 3 to the power 3 over 3. So can I know the answer here? How much is the I and j coefficients? Let's quickly calculate. So we get R equals 36i and the j coefficient is 15j. So basically replace all your t values with 3. Replace all your t values with 3 in the R equation and get the position vector. Get the position vector of A. Okay. Okay. So now we'll move on to question number 6. Okay, they say here a ladder AB has length 6 meters and mass 30 kilograms. The ladder rests in equilibrium at 60 degrees to the horizontal with the end A on rough horizontal ground and the end be on against a smooth vertical wall as shown in figure 3. A man of mass 70 kilograms stands on the ladder at point C where AC equals 2 meters and the ladder remains in equilibrium. The ladder is modeled as a uniform rod in a vertical plane perpendicular to the wall. The man is modeled as a particle. Find the magnitude of the force exerted on the ladder by the ground. Okay, so you can see it's a 6-mark question, right? So there's quite a lot of working you do here. Number one, first you mark all your forces. Okay, first we will mark all the forces. So they say here the ladder rests in equilibrium 60 degrees to the horizontal with end A on rough horizontal ground. Which means over here we have friction, right? And end B is against a smooth vertical wall. Okay, so when you make a contact with the wall, what do we have? At end A and end B, we definitely have normal reaction. So we have normal reaction A. And here I have normal reaction B. And to this side I have friction, right? Because you need to realize that the ladder, if it slips this way. So friction is to avoid the direction, it's opposing the direction that we are trying to move. So we are trying to slip back, so the friction will be moving the other way, opposing that, right? So this is the friction. The wall is smooth, therefore there's no friction at this corner. Okay, so remember again the normal reaction that when you are marking, you are not marking it perpendicular to the ladder here. You are marking it perpendicular to the surface that the ladder is touching, because normal reaction must be marked perpendicular to the contact surface. Okay, that's why I have drawn these two normal reactions in this manner. What else do we need to mark? We have the ladder has a mass of 30 kilogram and it's a uniform ladder, right? So they say the word it's uniform. The ladder is modeled as uniform rod. Yeah, thereby the weight acts exactly where? At the center. So it's 30G. Is that clear? And then what do we need here? So they say here a man of mass 70 kilograms stands on the ladder at point C where AC equal 2 meters. So I think you can see where AC should be, right? Because if the ladder is 6 meters, the center of mass is exactly at 3-meter point, right? Halfway, which means the man is at point C. So this is the place where the man is. And what's the weight? How much is the weight? 70G. Are you all with me? Okay, and then they say the ladder is modeled as a uniform rod and the man is modeled as a particle. Okay, so the weight acts at a single point. That's it. So they say find the magnitude of the force exerted on the ladder by the ground. Basically, they're asking you to find the normal reaction at A. So how do I find the normal reaction at A? So what are the things we do in this particular example? So my force diagram is now complete. So the only things we do here is we go for vertical equilibrium, we go for horizontal equilibrium, and we go for moments. So those are the 3 things we have to do. That's it. Go for vertical equilibrium, horizontal equilibrium, and moments. And here, so what I'll do here is now, can we use here the mu r friction? Do you think I can use the mu r friction here? For if no, because there's nowhere in this sum where they use the word this is limiting equilibrium. Though they say that the ladder is about to slip. Any of such? Do we have any such words here? No. Therefore, the friction here is not the limiting friction. It's not the maximum friction. Okay, so we can't use F equal mu r. Okay, so right, what we'll do here is this. What's the best thing to do here? Rather than going for up equal down, left equal right, first we'll go for moment. And what's the best place to consider moments here? The best place to consider moments here is actually not B. Now you might be thinking you want to find normal reaction A. But if you go take moments around B, there will be 2 unknown forces, normal reaction and the friction, which are both unknown. So I think it's best that we take moments around A. When you take moments around A, both of these forces will not be considered because both of them will not, both of them pass through A. When you pass through the point you're taking moments, they don't, we don't consider them for moments. Then I'll only have to work with 70G, 30G and the normal reaction B. Okay, so let's first take moments around B. So taking moments around B, the first force I'll need to consider here is now this is 2 meters. Okay, we'll take moments around A, moments around A. So I will take moments around A. Then let's take, start with the 70 meters. So how much of, what's the moment produced by 70 meters, clockwise or anti-clockwise? Yeah, what do you think? It's anti-clockwise, right? Can you see? Sorry, it's clockwise. 70G, it pulls it downwards. Do you see? It pulls downwards. So 70G is a clockwise moment. And what's the perpendicular distance? So this is the perpendicular distance, right? From point A to the force, it's the perpendicular distance. How much is it? 2 cos 60. It's 2 cos 60. So let's get it. The 70G into 2 cos 60. So I will consider clockwise as positive, okay? And then what about the moments produced by the 30G? I think you can see it's quite similar. The moment produced by 30G is also quite similar. Basically, the only thing that's differing here, the direction is still the same. It's pulling downwards clockwise. And how much is it? Plus 30G into 3 cos 60. Both are producing clockwise moments. The final guy is normal reaction at B. The final guy is normal reaction at B. So this is producing a what moment? So you can see it's pulling this way. It's producing a anti-clockwise moment around A. You pull this way. And what's the perpendicular distance? So this is the perpendicular distance, right? How much is it? 6 sine 60. Equals to 0. Now what do we do? Make R be the subject. So I'll take the normal reaction B into 6 sine 60 to the other side as a positive. Okay, and then we'll take this as a division. How much is it? Type everything in the calc. So you give G as 9.8, right? So what's the rule when you give G as 9.8 in the calculator? You must give your answer to either 2 significant figures or 3 significant figures. So how much is it? 216.8912, something we get like that. And don't leave the answer like this. Give it to 3SF. So 217 newtons. So this is reaction at B. So this is not done. What do we do now? What do we do now? We will now use vertical equilibrium and horizontal equilibrium. Okay, let's use vertical equilibrium and horizontal equilibrium. So vertical equilibrium, what do we have? Normal reaction A. So upward forces equal, downward forces equal 70G plus 30G. Do you agree? Normal reaction A equals 70G plus 30G. Thereby normal reaction A is 70G plus 30G is 100G. Okay. So that's normal reaction A. What about the friction? So this is up equal down, the vertical equilibrium. Now consider the horizontal equilibrium. The friction. Can you see what I'm talking about? The friction is equal to what? The friction is equal to normal reaction B, which means the friction is equal to 217 newtons. Do you agree with me? Okay, so now what do we do? They want us to find the magnitude of the force exerted on the ladder by the ground. Actually, when they say here the magnitude of the force exerted on the ladder by the ground, it's not just only the normal reaction. The problem here is when you take the ladder and the ground, it's not just the normal reaction you have here. You have the normal reaction and what? And the friction. So if you want to find the magnitude of the force exerted on the ladder by the ground, it's not just the normal reaction here, basically. It's actually both normal reaction and friction getting together, and you must find the resultant of these two forces acting on the ladder. So how do we find the force? Yeah, so we take the vertical force and the horizontal force and we square and root it. So we take the sum of the squares and we root. This gives us the resultant force at that point. So at this point, I want to get the resultant force. Normal reaction A is 100 G square, friction is 217 square root. Give the answer to give the answer to 3SF or 2SF. You could give this to more significant figures. There's no problem. You can give it to more significant figures here. So I get here 1003. Okay, I get here 1003.7375. So to 3SF or 2SF, we get 1000 newtons. Is that clear? In the next part, they say the man climbs further up the ladder. When he is at the point D on the ladder is about to slip. Okay, so what's happening now? Now at this point, when the man was 2 meters up the ladder, we did not have any problem here, right? But they say when this person now he keeps on climbing. So when you keep on climbing, there comes a certain point. What happens? Where the friction leads it, limiting the maximum friction because the more you go up, the more weight that the more the friction will the more chance, the more tendency that this is going to slip. So that means the friction will be the friction value. Now here we did not have the maximum friction in the earlier part, but now when you reach to a certain point up over here, the friction will reach its limiting value, and thereby what happens? Thereby we come to the place where the ladder is about to slip, and we have the mu r friction. So they ask you, given that the coefficient of friction between the ladder and the ground is 0.4, mu is given to you. Find the distance AD. They're asking you to find the distance AD. So shall we quickly alter on top of this diagram? Or you can draw another new diagram. So I'll quickly alter this. By the way, can we use the previous forces now? Can we use any of our previous forces? No, any of the previous calculations are not supposed to be used, okay? So you'll have to calculate every single reaction should be found new, because when the man is climbing up now, all these reaction values will change. Okay, the friction force will change, only the weights will be constant. Okay, so basically now I will use the reactions here. Shall I use two different letters? So let's say I used previously RA, RB, I'll use here R and N. I don't know, just use two letters. Okay, and now the person is at this point D. So let's say this is the point D. This is point D. This is the man, he's on point D. And the weight is how much? His weight is 70 G, right? This is the point D. We don't know the distance AD. We do not know the distance AD. So I'll say distance AD is what? X. Distance AD is X. Okay, so then what are we supposed to do now? They have told you the maximum friction. By the way, the ladder is about to slip. Therefore, we can use friction is equal to mu r. What is the mu value? 0.4 and r. So here we can use for friction 0.4 r. So it's easy for us to simplify them. So we know the friction value now, it's 0.4 r. So again, what do we need to do now? So what do we need to do now? Okay, so again, what is the thing we do? Again, we do vertical equilibrium, horizontal equilibrium, and moments. So there's no difference. Again, part B, it's the same story. But now in part B, we have more control. Now look, if you take vertical equilibrium, you can see R will be equal to 30G plus 70G. Do you agree with me? Which means normal reaction on the ground is equal to 100G. And if you take the horizontal equilibrium, we can say F is equal to N. Now F value is given here as what? 0.4 R equals to N. 0.4 times R is 100G equals to N. How much is N? 0.4 into 100 is 40G. So N is 40G Newton. R is 100G Newtons. Are you all with me? Okay, so I will keep it like this in exact form. Okay. Then what we'll do is, now I have my R value and I have my N value. Okay, so now what we need to do is, to get the distance x, we need to again consider what? Let's again consider moments. I'll again consider moments about whom? I will again consider moments about A, because I already know the sign cost ratios when it comes to taking moments around A. I found R is 100G. I found N is 40G. So let me mark N as 40G. Let's take moments around A, taking clockwise as positive. So when you take moments around A, what do we get here? Again 30G. What's the perpendicular distance? What is the perpendicular distance? 30G into 3 cos 60. Okay, so 3 cos 60 is this distance, the one that I'm marking in red now. This is the perpendicular distance from point A to this particular force, this horizontal distance. If your force is vertical, then your perpendicular distance is horizontal. Okay, if your force is horizontal, the perpendicular distance to the force and that point is a horizontal force. Now here 70G. 70G is a what kind of force? 70G is a what kind of force? It's a horizontal force. Sorry, it's a vertical force, and it's also pulling down. Do you see? 70G is also a vertical force pulling down. So what happens when you pull it down? So what happens? You create again a clockwise moment. So 70G into what's the perpendicular distance? So for the vertical force, the perpendicular distance is horizontal. What's the horizontal distance? I took this distance AD as x. So it's going to be x cos 60. Do you agree with me? And then the last guy is the 40G, and you can very clearly see the 40G is what? 40G is this way, right? 40G is anti-clockwise. So therefore minus 40G into what's the distance? Perpendicular distance is the whole distance is 6, right? So the perpendicular distance for the horizontal force, perpendicular distance is vertical. Do you agree with me? For the horizontal force, the perpendicular distance is vertical, this distance. So that is 6, not cos 66, sin 60. Do you agree with me? I erase the distance. And all of these moments must be equal to 0 because it's in equilibrium. So now what do we do? My moment equation is written now. It's a matter of making x the subject. Okay, so make x the subject and find the value of x. Okay, so they want exact value? No. 30G into 3 is 90G times cos 60. Seventy gx into cos 60. 4 into 6 is 240G sin 60. So G will cancel out. Okay, G will cancel out, and we just need to make x a subject. So 70 times x times cos 60 is equal to 240 sin 60 minus 90 cos 60. So x equals 240 sin 60 minus 90 cos 60 divided by 70 cos 60. How much is x? So basically here, yeah, we get a decimal figure, right? Yeah, 4.652745. Yeah, so give it to 3SF, 4.65 meters. Is that clear? So this is the answer for part B. So now we'll move to the next part. Part C, state how you have used the modeling assumption that the ladder is a rod. Okay, so these things we have even learned in M1, the modeling assumption. So the ladder is a rod means the ladder, you can say the main assumption we do normally go with the rod is that it doesn't bend. Okay, so that's the main assumption we learn. Okay, so you can say the ladder does not bend, or you can say, yeah, so we'll go with that. Yeah, you can say the weight acts at a single point. Yes. The weight acts at a single point. Or you could say the weight acts at a single point, any one. Any one of these two would be okay. Okay. Moving on to question number 7, they say the fixed point A is 20 meters vertically above the point O, which is on a horizontal ground. At time t equals 0, particle P is projected from A with speed 12 meters per second at an angle theta above the horizontal. The particle moves freely under gravity. At time t equals 5 seconds, P strikes the ground at point B where OB equals 40 meters as shown in figure. By considering energy, find the speed of P as it hits the ground. They're asking you to find the speed that you hit the ground. So basically the speed here. So speed is a scalar quantity, right? So we don't need to look into the direction there. And when you're using energy, basically you need to use conservation of energy here. So what are the energies we have? So I'll take the ground level as the potential energy 0 level. So at A, what are the energies I have? I have kinetic energy at A. I have kinetic energy at A, and I have the potential energy at A. Okay, and then at point B, what do we have? At point B, we have only the kinetic energy. Because when you come to the ground, you are in the potential energy 0 level. Therefore, there's no GPE. So I get here kinetic energy at A is half m into v squared. So the 12 square. Plus gravitational potential energy is mgh. H is of course 20 here, right? mgh, the height, vertical height above the ground is 20. Equals kinetic energy is half mv square here. One v is unknown. So basically here everyone has a letter m and I can remove it. Okay, so we'll multiply the whole equation also with the 2. Then I get here 12 square plus 20 into 20g times 2 is 40g equals v square. Half v square into is v square. How much is v square? 144 plus 400 is 544, right? So v equals to root 544, which is how much? So I get here 23 point, again, wait, 12 square plus 400. Sorry, it's not 400 here, right? This is 40g, isn't it? Yeah, it's not 400. It's g times 20. When you multiply with 2, it's 40g here. Okay, so then we need to add, okay, sorry about that. So 12 square plus 40g. So 12 square plus 40g is 536. I use g as 9.8. This is 536. V is the root of it. So square root of 536 is 23.1516. 23.151673, something like that. So when I correct it, definitely give you an answer to 2SF or 3SF because we use G as 9.8. So 23.2 meters per second if I correct this to 3SF. Is that clear? Then moving on to part B, find the least speed of P as it moves from A to B. So when the particle moves from A to B, the next thing you need to realize is how to calculate the least speed. Least speed is normally in a projectile. We say the lowest speed is normally occurring at the highest point. Why is it the lowest speed at the highest point? Because at the highest point, the vertical component of velocity will be 0 at the highest point. Okay, so and then you need to know that in a projectile, the horizontal component will remain constant throughout the motion because horizontal component doesn't change. 12 cos theta, it will be 12 cos theta throughout the entire motion. Throughout the entire motion, it's 12 cos theta. Okay, so basically the lowest speed we have here is what? The lowest speed we have here will be 12 cos theta. Okay, so we will have to find the value of the theta here. Okay. Okay, so how do we find the cos theta value? Basically, they have told us that the time taken to move from A to B is 5 seconds and O to B horizontal distance is given to you. So I think we can find the cos theta value quite easily by using S equals UT horizontally. So when you go horizontally, we don't have a gravitational acceleration. The horizontal displacement is 40. And the U value is, when you're using these equations, these are vector. These consider directions into account. Therefore, you can't just use the initial as 12. That's a speed. So you need to give the component of the speed, which is 12 cos theta in the horizontal direction. So 12 cos theta into times t is 5. So then we can get the value of our cos theta. Basically, I want 12 cos theta actually. So 12 cos theta is 40 divided by 5 is 8. So 12 cos theta is 8. So the horizontal component is 12 cos theta, which is 8. And that's what we need. So this is the lower speed, because at the highest point, there is no vertical component. There's only a horizontal component. So that will be the least speed. Will be 8 meters per second. Is that clear? Let's move on to the next part, part C. The next one, part C, find the length of time for which the speed of P is more than 10 meters per second. Okay. So they're asking you to find the time where the speed is more than 10 meters per second. So first of all, do you understand the mechanism of this projectile? Normally, when you are moving up, are you gaining in speed or are you losing in speed? You are losing the speed, right? So basically, now, and the other thing you need to realize is the projectile is very symmetric. Basically, if you go right across A to the other side, I mean, if you come to this point and mark the speed, what will the speed be? It must be 12. Over here, if it's 12, over at the other opposite end, it must again be 12. Even the angles must match. Okay. So now they want us, now you need to realize that the speed is decreasing, right? So speed is decreasing. So they want, I mean, there's a point, there's a time over here where the speed actually reaches a speed of 10. And then the immediate opposite, the other side also, again, we have the same person where we have the speed 10. So I think you need to realize here that on top, that above this particular section, we have the speeds that are what? Lower, more than 10 or less than 10. These are the speeds that are less than 10, this time duration. So every other time duration, I mean, like the whole thing is 5 seconds. So if you can find this particular time duration and remove all the other entire time duration, it's traveling at a speed more than 10, right? Are you with me? This particular time duration is the only one where the speed is less than 10. The yellow color duration. Do you agree with me? So the thing that I need to do here is now, and we know the lower speed is 8, right, at the top. Therefore, 10 has to be somewhere over here, and right equal, and I mean directly opposite, we have to have the other place where we have 10 meters. Now, my first priority is I'll try to find this yellow color time. How do I do that? How do I do that? The first thing I do here is there are many ways of getting this done actually. So what was the technique that you all used? So previously we found that now you know the horizontal component throughout the entire motion. Does it change? The horizontal component of velocity throughout the entire motion is a constant, right? Now we just found out in the earlier part 12 cos theta was what? The horizontal component 12 cos theta is what? 8. Are you with me? 12 cos theta is 8. Thereby this is 8. And let's say the angle at 10 meter per second is alpha. Can't I find the alpha value now? Do you understand what I did here? I used the horizontal component of the velocity as 8 because horizontal component is the same throughout the entire motion. So this over 8 here is 8 everywhere, the horizontal component. And the angle here is definitely different. I'll use it as alpha. So I can say here now what? 10 cos alpha is equal to 8. Are you agreeing? Do you agree with me? So 8 divided by 10. 8 divided by 10 is 4 over 5. Cos alpha is 4 over 5. So I can get the sin alpha value. What's the sin alpha? If cos alpha is 4 over 5, cos alpha is adjacent over hypotenuse. I did a right angle triangle. So what is the opposite? 5 square minus 4 square, square root, which is 3, right? So sin alpha is opposite over hypotenuse. So which is 3 over 5. Is that okay? Sin alpha is opposite over hypotenuse, which is 3 over 5. So then I can now get the vertical component. Do you see my vertical component is 10 sin alpha? Do you agree with me? Equal opposite on the other side. Again, I have this horizontal component 8. And the alpha should be here. Can you see the way I'm marking? Shall I make my diagram slightly larger? So on the other side, again, I have my horizontal component 8. The angle here is again alpha. Okay, so this side I have now what? I have the 10 sine alpha. Are you with me? This is the 10 cos alpha. This is the 10 sine alpha. So what I'll do is first I'll find the time duration from here to here. Between these 2 points, I'll find the time duration. Yeah, so then this, to find this 10 sine alpha, you could even use Pythagoras because here you have 10, here you have 8. So you could say 10 square equal 8 square plus this value here square equals to, 10 square equal 8 square plus this value here. And then get this value as 6. Okay, so that can be also done. Okay, so first I'll find the time duration for the yellow color part that I've marked. So I will use what? V equal U plus 80. I'll use V equal U plus 80 upwards. So final velocity is from here to here, it's 10 sine alpha, right? 10 sine alpha, I'm using it upwards. My 10 sine alpha is downwards. U is 10 sine alpha upwards. G is negative 9.8. Minus, I'll put minus G because we have marked the equation upwards. G is negative upwards and time is T. So I get here GT equal 10 sine alpha plus 10 sine alpha is 20 sine alpha. 20 times sine alpha is how much? Sine alpha is 3 over 5. 5 times 1, 5 times 4 is 20. 4 times 3, 12. 12 divided by G. T equals 12 divided by G. Is that okay? So that's the time duration from here to here. So then what's the time duration where I travel at a speed more than 10? Time where speed is more than 10. So we know the entire duration of the entire thing is 5 seconds, right? From that we should subtract the 12 over G and then we should be able to get we should be able to get the time duration that we are traveling more than 10 meters per second, because you need to realize that these times, so basically I'm going to get the times that I'm marking in red here, this part and this part. I'm going to find these two time durations. So can you all tell me the answer here? What's the value? So 5 minus 12 over G gives me 3.7755, basically 3 SF answer. Make sure you give 3 SF answers. 3.78 seconds. Is this clear? And remember here the 12 over G is the time duration where the speed is actually what? This is the time duration where speed is less than 10. Okay? In an event you need it. This is the time duration where the speed is less than 10. So for the speed more than 10, from the entire time duration, we subtract the 12 over G. Okay? Is that clear? Okay, so now let's move on to question number 8. They say two particles A and B have masses 3m and 4m respectively. The particles are moving towards each other along the same straight line on a smooth horizontal face. Okay, so I have my two particles A and B. So this is A, this is B. They have masses 3m and 4m. The particles are moving towards each other along the same straight line on a smooth horizontal surface. The particles collide directly. You can see they collide. Immediately after the collision, A and B are moving in the same direction. So they are moving in the same direction, okay, with speeds U over 3 and U. Okay, now when you are marking this, the speeds, now they have not mentioned the direction, but you need to use your common sense here. When they say they are going to the same direction, either both of them are going to the right or both of them are going to the left. So now you need to decide whether you are moving both directions to the right or to the left, and that needs to be correctly decided. So can we mark U over 3 and U in this manner? So U over 3 and U. Now we definitely know U over 3 is lesser than U, right? So after the collision, can I have the speed of B and A going to the same side? Can B be bigger than A and can both of them travel in this manner? You can see it definitely doesn't agree, right? It doesn't agree. U is bigger than U over 3. Thereby, after the collision, you can't have a speed that goes like this. Okay, the speed of B is greater than the speed of A. So there's again another, we can't move like this. Particle B can't move because particle A is in front of it. So thereby we need to realize the correct directions to apply after the collision is u over 3 and u to the right side, because in that case you can see B has a higher speed u, A has a lower speed u over 3, so A is going behind while B is going forward. Okay, so this is the first thing. You need to figure out the correct directions of u over 3 and u. And they say in the collision, A receives an impulse of magnitude 8 mu. Okay, so we'll quickly go back to the question. So where were we? We were about to take, so we are supposed to find the coefficient of restitution between A and B, and I was explaining about the directions. They say after the impact, A and B are moving in the same direction with speed u over 3 and u, and I was saying you that you must mark u over 3 and u in this particular direction, because u needs to be, u is higher than u over 3, and this is the only side that makes sense in this question. And then they talk here about the impulse. So you do realize when A and B collide, the impulse on A is backwards and the impulse on B is forwards. This is the impulse. Okay, so let's use I equal mv minus mu on A. I equal mv minus mu on A, and I'll use it backwards because backwards is positive. So I equals to 8 mu. Equals mass is 3m into final velocity is u over 3. However, u over 3 is to the front side. So if I mean, you can see u over 3 is to the forward. Okay, so I'm choosing the backward direction as positive here. Okay, so we'll need to change them afterwards. Okay, mv minus m is again 3m into u is x. U is the initial, x is also forward. So I'll need to change both of these directions by giving a negative sign. So I get here 8 mu minus the 3 and 3 will cancel minus mu, and this guy, when the minus marks coming when the minus mark comes in front, it becomes plus 3 mx. Okay, it becomes plus 3 mx because I changed the direction of both of them. Okay, and then m is common to everyone, we can cut them out, make x the subject. So what do I get here? 8u minus u comes as plus u equals 3x. So I get here 9u equals to 3x, which gives me x equals 9u divided by 3 is 3u. So this is the initial speed of A. Then we'll use I equal mv minus mu on B and get the initial speed of B as well. Okay, because we need to find the coefficient of restitution between A and B. To find the coefficient of restitution, I need the speed of separation over speed of approach, which means I need all the 4 speeds here. So I need to find both x and y. I equal mv minus mu on B. Please consider the direction. Now for B, the impulse is acting forward. So I will take the right side direction as positive because B has the impulse acting forward. Okay, so then impulse value is 8 mu. So impulse is equal, and impulse is the force that acts on both the objects, equal and opposite, right? So I is 8 mu on B as well. So mass and final velocity is u. So this one, there are no problems. The directions are all agreeing, right? And then minus mu. U is y, and you can see we have a problem with y. Y acts backwards. Y is to the left side. Do you see? So we need to fix that. So I get here 8 mu, and then I need to change this guy's direction. When I change the direction, I get another negative, which makes it positive my. Do you agree with me? So m will cancel out. M will cancel out, right? Sorry, I think I used my mass wrong. Sorry. My mass should be what? Mass of B is 4m. Actually, mass of B is not just m, but 4m. So this is 4mu, this is 4my. Okay. I hope you guys saw that mistake. Okay. The mass of B should be 4m. Don't just use m here. I mean, for A also I use 3m. Mass of B is 4m. So I cut them here and I get here 8u equals 4u plus 4y. Okay. Is that okay? Okay, so 8u minus 4u is 4u equals 4y, and then y equals 4 divided by 4. I get y equals u. Do you agree with my answer? So I get here y value is equal to u, and I get here x value is equal to 3u. Do you guys agree with me? So now we need to find the restitution. How do we find restitution? E equals speed of separation. Speed v2 minus v1 over u1 minus u2. Choose a positive direction. Always choose a positive direction. And if anyone opposes that, then that person is negative. Choose a positive direction, and this is how I use restitution. V2 minus v1 over u1 minus u2. You can see I have switched on purpose. I mean, I have switched it. Okay, so this is the restitution law. V2 minus V1. So let's say the X is U1, the Y is U2. Okay, initial speeds are U1, U2. Final speeds are V1 and V2. Is that okay? So according to what I have marked, V2 is U minus V1 is U over 3. So directions are okay. They agree with the original direction that I've used as positive. Over U1 minus U2. U1 is 3U. 3U is also positive to the forward side. U1 minus U2 is U. But the thing is U2 is U and it acts to the left side. You see? Direction doesn't agree. So we need to change the direction and fix it. So I get here U plus U minus U over 3. How much is it? 2U over 3. Divide by 3U. This becomes plus U. Do you agree that when I change the direction, the minus should become a plus? So basically, I end up getting here 2U over 3 divided by 3U plus U is 4U. I wrote it like this. Are you okay with it? Same thing, right? 2U over 3 divided by 4U. So I get here 2U over 3 division to multiplication, and it's 1 over 4U. U and U cancels, and I get here what? 2 times 1, 2 times 2 is 4, and I get here 1 over 6 is equal to 1 over 6. Okay? This is clear. This is the answer for part A. Moving on to the next part, they say when A and B collide, they are at a distance D from a smooth vertical wall, which is perpendicular to their direction of motion. Okay, let me draw this. So we'll draw a series of diagrams for this question. So when A and B collide, okay, they are at a distance what? They are at a distance D from a smooth vertical wall. Okay, let me try to draw it as evenly as possible. Okay, so this distance is D. Are you with me? The distance from the wall to the place where A and B collide is D. This is at the initial stage. So then what do they say that next? They say after the collision with A, particle B collides directly with the wall. Now you can see this is particle A, this is particle B. And you know, after the collision, you know their speeds, right? B moves forward with what? With speed U. A moves forward with speed U over 3. These are the two speeds after the collision, right? So definitely you can see B moves faster than A. So which means B will reach the wall first. And it will hit the wall and rebound back. Do you agree with me? They say after the collision with A, particle B collides directly with the wall and rebounds so that there is a second collision between A and B. Makes sense, right? B is moving forward now. It goes front while A is going behind. A is a little bit back. B is going forward. It comes over here, hits the wall, rebounds back, and meanwhile A is still making its way. And then they again collide somewhere over here. Do you get what I'm talking about? Okay. So basically, if I draw my diagram again, what's happening in the second diagram? In the second diagram, B has reached the wall. Can you see in my second diagram, B has reached the wall. Okay, but while when once B reaches the wall, does it mean that A is still over here? No, while B reaches the wall, A also has moved a certain distance forward. Isn't it? So I'll say A has moved over here. Do you agree with me? Do you agree with me? So we'll say this particular, so A is still moving forward with speed U over 3. Okay? Okay, and then the next thing you have to do is after that, after B collides with the wall, what happens? It will rebound, right? It rebounds and it comes back. It comes back, and the thing is you have to find the speed of rebounding here. The rebounding speed from the wall, and then again they come and meet over here. Do you agree with me? Let me draw the diagram again. 3 diagrams. I'm drawing 3 diagrams here. So this is the distance. I'm still keeping the original distance D here. Can you see? Can you see my diagram? I'm drawing everything on top, on one below the other, so everything is clearly to be seen. Then in the next diagram from this point, A is now while after B rebounds from the wall, so they'll both meet somewhere in between, right? Do you agree with me? Not, we can't say it's the middle, but they will meet somewhere in between. Okay, right. So then what we'll first do is, shall we calculate the speed that B rebounds from the wall? How can I find the speed of rebound? Yeah, we can use E equals V over U here, right? E equals, because when you hit the solid wall, speed of, separation over speed of approach, we only have one moving object here. So we can directly use E equal V over U when the object impacts with the wall, or if the object impacts with the ground. So we normally use E is V over U. We don't need to use the V2 minus V1 over U1 minus U2, because there's only one moving object. So we directly use V over U. Directions are already considered. Do we need to put directions and put negative signs here again? No, this is a standard equation. Directions have already been considered. So you just need to put the value. E value was how much? The restitution between B and the wall is 1 over 4. B is the final speed, the speed after the impact. U is the initial. So initial speed is before the impact. Before impact speed is also U, which gives me what? The after impact speed is U over 4. Do you agree? So after impact, B moves with speed U over 4. Do you agree with me? So B moves with speed U over 4, and while here A is continuing with speed U over 3. Does it work into your head? Now what are we supposed to do here? What are we supposed to do here? They say, what is X here? After the collision with A, particle B collides directly with the wall and rebounds, so that there's a second collision between A and B. This second collision takes place at a distance X from the wall. So do you see what is X now? Distance X from the second collision takes at a distance X from the wall. Can you see the X distance now? This is the place where the second collision takes place between A and B. Are you with me? So when the second collision takes place, it's at a distance X from the wall. Your task is what? Find X in terms of this D. Your task is to find X in terms of the D. Okay. Shall we do this methodically? So what we'll do here is this. So basically this is moving with constant velocity, right? There's no acceleration. So I can use S equals ut. Shall we use S equals ut for A and B at the beginning? So for the first diagram, I'm going to use S equals ut. S equals ut to B. Okay, so when I use S equals ut to B, so how much of a distance does B travel to hit the wall? It travels a distance D. The speed is U, and let's say time T1. So what's T1? T1 is the time taken for particle B to travel a distance D until it hits the wall. Do you agree with me? So I get time 1 is D over U. Do you agree if I say time 1 is D over U? And during that exact same time gap, what is particle A doing? During that exact, now you know A and B, while B travels to the wall, let's say A has traveled to this point X, right? Let's say I'll name it point X. When B traveled to the wall, at that same time duration when B traveled here, A has traveled from here to here. Time duration is exactly the same, right? So we can find what now? We can find the distance that A traveled forward during that time gap. So shall we find the distance that A moved forward during the time gap D over U? So find that again, what do we use? We use S equals ut to A. And we find, what are we trying to find? We find how much of a distance A moved forward when B moved distance D to the wall. So the distance is unknown. S. U is the distance moved by, the speed of A is U over 3. Time T1 is what? D over U. Do you agree that the time T1 is D over U? So U to U cancels. S is D over 3. So you can mark it on your diagram. Go to your diagram. Mark it as D over 3. So this distance is D over 3. This distance is D over 3. Do you agree with me? Can I have the remaining distance then? If we have traveled distance D over 3 forward, how much of a distance is there between A and B when B has reached the wall? D minus D over 3, because the whole thing is D. From D we subtract D over 3. What do we get? 2 over 3D. So 2 over 3D is the distance between A and B once B reaches the wall. So now what's happening? Now we need to consider and work with the distance 2D over 3. So from the distance 2d over 3, now you can see particle B, they say it has traveled a distance x, right? From the wall. So I mean, you can see here now the next part of the question, I need to do it with this particular distance, with the 2d over 3 distance. Can you see? So from the 2d over 3, they have said that the distance between B and the wall is x. Can you tell me the distance A has moved in terms of x? In terms of both D and x. What is this distance? 2d over 3 minus x. Does that make sense to you? Look, this whole distance is 2d over 3, right? Are you watching this? The whole distance is 2d over 3, and this part, this particular part between B and the wall is x. So from the entire 2d over 3, if you subtract this x, you get the part, the distance that A has moved forward. Isn't it? For the second collision. Okay. So now we'll consider this part of the motion. So now now let's take the time gap, time 2. The time taken for particle B to travel from the wall until it collides with A. And in that same time duration, particle A is moving from where? Particle A is moving from point X until it collides with B. Do you agree with me? Particle A is at this point X while B is over here, and then they are both moving towards each other. Together they are moving and they come to a certain point and they collide. Right? So the time taken for, let's say this is point Y, the point of collision is Y. The time taken for A to move from X to Y and the time taken for particle B to move from the wall to this point Y is exactly the same. Right? Because particle A is at X and particle B is at the wall at a distance 2d over 3 apart. Okay? Do you agree with what I'm saying? Particle A moves while particle B moves x distance from the wall to the point of collision. Particle A is moving a distance 2d over 3 minus x until it meets point B at the point of collision. Okay, so let's do again. What do we need to do again now? Again, we will use S equals ut on whom? On B. This time it's moving behind, so I will use backwards as positive. What's this? What's this? X. U is u over 4. It's now moving with the speed u over 4. Time is t2. So t2 is 4x over u. Do you agree? So again, what do we do now? Now we use S equals ut on A. And what's the distance moved by A during that same time gap? During the time gap t2, A has moved the distance 2d over 3 minus x equals u is u over 3 and time 2 is t2 is 4x over u. Do you agree with me? So they want you to find an expression for x in terms of d, right? Do you see that I'm getting here now an expression for x in terms of d? So x in terms of d means make x the subject. Here u and u cancels. 2d over 3 minus x equals 4x over 3. So I get here 2d over 3. You can multiply the whole thing with 3 if you prefer. You could multiply the whole equation with 3. So I get here 2d over 3, 4x over 3 plus 3. So 3x over 1, right? Basically, you multiply both up and down by 3. So I get here 7x over 3. Do you agree with me? Then making x the subject, I get x equals 2d over 3 into 2d over 3 into 3 over 7, right? So the 3 and 3 cancels out. And x equals what? 2d over 7. So this is the expression for what? X in terms of d. Are you clear with this? Okay, so this is the end of the Jan 2021 M2 paper.